Okay, this is our last chapter for this course, chapter 10, and it's about radicals, okay? And square roots are radicals. So when we square a number, you multiply the number by itself. To find a square root, we want a number that when multiplied by itself results in that number. Okay, so the number a is called the square root of a squared. Okay. So the positive or principal square root of a number is written with this symbol. Okay, and that's called the radical sign. For example, the positive square root of 121 is 11 because 11 times 11 is 121. Okay, or we can write it like this: 11 squared is 121. The negative square root of 121 is negative 11. Now, I cannot have a negative inside a square root, right? So that would mean something like this: negative square root of 121. Oops, I missed my negative. Is negative 11. If I had a negative inside the square root, we're going to call that not a real number, and we'll pick that up in college algebra. I don't think we do those at the end of this chapter. Anyhow, at the end of this chapter or college algebra. Okay, that's where we're going to begin college algebra. Okay, so because think about this, technically negative 2 squared is 4. So the square root of 4 could be technically plus or minus 2, but I can't have a negative under a radical. So the radical symbol or the radical sign always represents the positive square root. Now they're saying this because 0 is neither positive or negative. So square root of 0 is 0. The number inside the radical symbol is the radicand. So right here, 121 is the radicand. The entire expression is just called a radical expression. So just a little terminology there. And this says find all square roots of 64. Be careful on your homework as to what the wording is. Find all square roots of 64. This is what we were just talking about. Technically, the square root of 64 is 8 because 8 squared is 64, right? But don't forget, the square root of 64 could also be negative 8 because negative 8 all squared is also 64. Okay? That makes sense? So pay attention, does it say find all square roots or just find the square root? Because if it just says find the square root, we're talking about the principal one. So you should probably make a list somewhere of your squares and cubes. So let's write them right here right quick, because you're going to need to recognize these numbers. We talked about this when we were factoring too. Till at least 13, maybe 15. Okay, so 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared 81, 10 squared 100, 11 squared 121, 12 squared 144, and 13 squared 169. So I need to recognize this number. Okay, the square root of 169, that's 13, because 13 squared is 169. Now remember, if the negative's outside my radical, my answer is just going to be negative. If it's inside the radical, we can't have it and stay in the real numbers. So notice 225 is not over here. But hopefully when we see numbers with 25 on the end, we're thinking of factors with 5 in it. And it's not a lot bigger, so maybe the next one, if it's not 10, let's try 15. 5 times 5 is 25. 5, 6, 7. Oh, yeah, 225. Right? So negative 15. Because 15 times 15, 15 squared is 225. Okay? We have a handy little rule that's our product rule and quotient rule that actually we'll talk about in one of the future sections, but it says as long as there's no plus or minus, right? No plus or minus, okay? Then I can separate anything being divided or multiplied into their own radicals. So I don't have to think, oh my word, I need a fraction that when I multiply it by itself gives me this giant fraction. No, just do the numerator and denominator individually. Okay. Okay, now once again, pay attention to the instructions. This does not say find the square root. It says find the square. So it wants you to square this number. If you square a square root, they get to cancel. So the square of the square root of 17 is just 17. All right, now I've got to square this whole expression. Square the whole expression. So when you square a negative, it's positive. And then when you square a square root, it gets to cancel. Okay, when you square a square root, it just undoes it and leaves whatever is under the square root. So pay attention. Or your instructions saying find all square roots, find the square root, find the square of the square root. Yeah, it could be really confusing. Okay, rational, irrational, or not a real number. Okay, if the number is a perfect square, the radicand, the number underneath the radical sign, is a perfect square, then our answers are rational numbers. Okay, if it's not a perfect square, if I can't find a number that I can actually take the square root of, like that first one on the previous page, nothing times it's, well, I don't want to say nothing, no whole number times itself equals 17. These kind of numbers are irrational. And then, of course, if we have a negative underneath here, those are the ones that's not even a real number. Okay, so tell whether each number is rational, irrational, or not a real number. Is there a number you can multiply times itself and get 27? Nope. So this one is irrational. Okay, is there a number you can multiply by itself and get 36? Yeah, 6. So this one is rational. Okay, I don't even care about the number part. I can't have a negative under that radical, so I know that one's not a real number. Okay? Okay, what about higher powered roots? Okay, so notice before we said these are square roots. If there's not a number written right here, okay, and this number written inside here is called the index, it's understood to be a 2. You could write it there. It's not wrong to write it there. It's just we don't need to write it there. It's like saying if there's not an exponent written, it's understood to be a 1, right? If there's not an index written, it's understood to be a 2. But there could be other numbers in there, okay? And it means the same thing. For example, I could have the cube root of 8 is 2, because 2 cubed is 8. So this just means I'm looking for a number that when I multiply it by itself 3 times, it'll give me 8, right? So 2 times 2 is 4 times 2 is 8. Okay, so you might also want to make a list of your cubes. Let's make that. So till at least 10. 1 cubed is 1. 2 cubed is 8. And no, you won't have this list on your test, but you can recreate the list. Right? By just how? By just saying, oh, 4 times 4 is 16. Times 4 is 64. If you have to go over to the side, fine. But hopefully you'll recognize these numbers pretty soon as we work with them. I just forgot what 9 cubed was. Not 500. 729, and then 10 cubed is easy. It's 1,000. Okay, so get used to recognizing these numbers. And then if I'm finding its cube root, oh, I need a number that when I cube it, it gives me 64. Here it is. That's 4. Notice 64 is on the square list and the cube list. Now, negatives, if your index is odd, it's okay. Because if I had negative 2 cubed, that gives me negative 8. So if I have a negative underneath an odd index, my answer is just going to be negative. Right? If I have negative 2 squared, it's positive. I can't have a negative under here because anytime you square a number, it's positive. Okay, so the cube root of 27 is 3 and negative 3. 512, it's on my list, so the cube root of 512 is 8. Okay, if you have higher roots, I wish I'd have said this before I erased that last slide. If you had higher roots, notice from the list you wrote down, hopefully, how quickly those numbers get big. Okay, when we're just squaring them, 10 squared is 100. But when we're cubing them, by the time we get to 10, we're at 1,000. So imagine if we multiplied them by itself again, the numbers get really big. So for the most part, not 100% of the time, but for the most part, if you've got 4th or 5th or 6th roots, then you're probably looking at 2 or 3. Okay, or else the number is going to be huge. So this is an odd number. It's not going to be 2. Let's see what 3 times 3 times 3 4 times is. Oh yeah, that's 9 times 9. Okay, 3 to the 4th is 81. That means the 4th root of 81 is 3. Okay, this is the same thing except I got a negative outside, so it's negative 3. Now, if you've got a negative and the index is even, that's not a real number. It's okay if the index is odd. Not even. Not a real number. All right, 5th root of 243. Again, I can tell it's not 2. So let's try 3. 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. I already know this is 81, right, from up there. So 81 times 3 is 243. So this is 3. And this is what? Negative 3. Right. It's okay if your index is odd. It just means your answer will be negative. Okay, again, pay attention to instructions. Find each square root. Okay, anytime I have a square and a square root, they can just undo each other. Right? So this will be interesting for in the future. We'll talk about this. I can write that either this way or this way. Same thing. Okay, a square and a square root undoes each other. Now, I got to be careful with this negative under here. So in this case, I do have to think about, hey, if I square this negative 12, it's 144. And the square root of 144 is just 12. Right? If it was written like this, that's not a real number, because this would be the square root of negative 144. Remember those exponent rules. Okay, but this is the square root of positive 144, because when you square a negative, and if it's sitting on parentheses, it goes to everything in the parentheses. Same thing here. That would be y. And the same thing here. What would this be? Also just y. Yeah, also just y. Because this square makes that positive. So when you can take the square root of it. If it looked like this, it's not a real number. One more. Okay, find each root. Okay, what do you think this is? Yeah, these 4s are going to undo themselves, but what about that negative? Yeah, it's not going to be there, right? Because when I raise this negative to the 4th power, this is really going to be a positive number. So it's okay to take the root, the positive root, the even root, sorry, the even root. All right, but what about this one? When it's odd, my negative stays. Okay, if I raise that, this means I'm going to multiply 5 negatives times itself. So when I get done, whatever number 5 to the 5th is, 5 times 5 times 5 times 5 times 5 is going to be negative. But that's okay. If I've got an odd root, I can have a negative underneath there. All right, be careful now. I got a negative outside, so that has nothing to do with the problem. Okay, now, if I raise a negative to the 6th power, or multiply this negative times itself 6 times, it's going to be a positive number. And those will undo itself. Okay. All right. I know sometimes that's a little hard to swallow. Okay. Let's look at these last ones, though. I know this is going to be negative because it's outside, has nothing to do with the radical. But think about this. If I could make what's under here a 4th, I know that they just cancel out, right? But it's m to the 8th. Isn't that the same thing as this? M to the 4th times m to the 4th. And then we remember what we said, as long as everything's being multiplied, I can separate each one into its own little radical. And when it's written like this, these just completely cancel out. Whoops. So this would be m times m, or m squared. So mathematically, this is what we're doing. But notice, hey, how many times does 4 go into 8? 2. Hey, how many times does 3 go into 24? 8. Hey, how many times does 6 go into 18? 3. Okay, so if we have variables under there, it actually becomes really easy to simplify it. All I have to do is figure out how many groups of y to the 6 I can make. It's because I could change that to y to the 6, y to the 6, y to the 6, right? 6, 12, 18. So how many of these are there? There's 3 of them. All right, practice that. Let me know how it goes.